So today we'll start this part. So here we have to create a closed body. So closed body, here first we need to create a tooling direction, parting line, then thickness as per the master section. So here new thing is like thickness value is not given. So sections are given. Sections are means these lines you can see the sections. Okay. So as per the sections we'll see how much the thickness and all the style analysis also we need to run. Okay, on the style. So input data is here I received. So this is the input data I received. Okay. So sound you can check your internet connection. I think my sound is okay. Everybody please check your sound. Am I audible clearly?
Yes, sir.
Okay. Prathamesh, you check your internet connection. Okay. So here, this is the style we received, right? So this style I'll copy as it is and we'll paste into our standard tree structure. Standard tree structure last session we created that only you can use. Okay. Only use it every time, no need to create and fit it. And we'll reorder this geometric set top of the input. Okay. So this is the style I received. Okay. And in the style, if I open it, these all surfaces belong to class A surface. Okay. So I'll copy this all the surfaces as it is. And then we'll hide this all and style received define paste special as a result. Okay. So we have style received as it is. This is the style I received. Okay. As it is. So you can change the date. Okay. Whenever you are working. Today you are working. Today's dates. Revision 1. After this, now I need to create a class A surface. So I'll define the A surface here. And we'll go to the join command. Okay. And merging distance is how much? 0.01. Okay. Report when we are generating. That time we are keeping here. And distance propagation. Okay. Review. And check tangency. No tangency error. Click OK. Okay. So both the things check. No sharp edge. Okay. No missing surface also. No missing surface. Only outer boundary it is showing green. So all the three basic checks done. Now tooling direction creation. So tooling direction creation here we created for this part if you remember, but again I'll create. So here what you need to do first to create a tooling direction, I'll use the measure inertia command because here I don't know is this automotive part or non-automotive part. So I'll select this inertia command, select this, okay, and blue line will follow. So blue line you can see. So that blue line we need to follow. So create geometry CG axis system. So blue line we need to recreate. So blue line is parallel to the Z axis. Okay. So I'll define the main tooling direction. And here line I'll take point and direction. So point is this and direction is blue Z line parallel. Blue line was parallel to Z, right? And now I'll change this mode to the this. Now we'll check the analysis, craft analysis, right? Is it clearing or not? So for that, I'll change this to the material mode. Select this. We'll change the distance, classes surface 2.98. And here, I'll match this line to this axis. Here also again, reorient it, lock it, and select the classes surface. So we are getting two undercut areas, right? Undercut means this is less than 0. This is also less than 0. So less than 3 degree means this is the undercut we are calling. Okay. So if I check the values, how much the values? This value is minus 16.62, right? Minus 16 is a like greater value, right? Minus 16.5, minus 16.7. Here also the undercut is there, right? So that is also minus 9, minus 12. -8, -10, -12, right? So minus 16 point something is value is a greater value, right? -16.23 is coming. So here our undercut is at the same location, right? Same direction. This direction and this direction, the direction is same. Okay. So here this line I need to rotate in trial and error method, right? Either this direction or this direction. So how much the angle we need to rotate? Our formula means if I want to turn this surface green, then this surface value should be 3 degree. So if 3 degree I want minus in the bracket minus 16.54 is coming. So I'll take a round up value -17. Okay. And 3 plus 17 answer is 20. Right? Minus minus plus. So 20 degree we need to rotate this line to clear these patches. Okay. I already explained. That's why I'm taking fast. If you not understood, check the session number 4, tooling direction methods. In that, we explain this with the trial and error method. Okay. Now this line I'll rotate at the 20 degree. Angle normal to curve. Curve this I need to rotate. Point is this. And support is parallel plane. That is this plane. Reverse direction. Angle is 20. And this original line I'll hide. Okay. And if I double click on the draft analysis and I reorient this, so I will get a new result. Match this. Again match this. So you can see your part is clearing completely. Completely green means clearing into the tooling direction. So this is my final tooling direction I can consider. Okay. Like this with the inertia and trial and error method using, we can create the tooling direction. Okay. So part is also clearing. So I'll give the 1 and 2. Then here classes surface is done. Analysis done. Tooling direction done. Now thickness means offset value how much. So here you can see sections are given, right? So here what we need to do, create one plane with 3 points. Okay. And here I'll select 3 points. Any 3 points onto the section you can select randomly. You can get this plane parallel to the section. Now you can use the sectioning command here at the bottom and select the plane. This. You can get the cut section here, right? Exactly cut section. So if you see the section here, what is the section? Here section is given that this top line is following the classes surface and this is the offset line. So offset line, how much that we need to check. Okay. So how can we check here? We can take the we'll take the measure command and here point to point we need to check from this point to this point it is 2.5 mm. This point to this point it is 2.5 mm. Okay. This point 2.5 mm. So 2.5 mm is a common value. It is not checking properly, but point to point if you check, it will give you the value. It is in a angle, that's why it is showing more value. But 2.5 face to face, if you check point to point face says it will show you. Otherwise, edge to edge also you can check. Okay, so 2.5 is a common value. So we need to offset here 2.5. So our B surface we can create. Okay, like this you can measure the values from the sections also. If section value is not given in the offset, you can measure the section. Now this is my class A surface, so I'll give the color. Now class B surface generation, define the class B and I'll offset it by 2.5 mm. Okay, this is a visible side, so offset will be opposite side. select this surface 2.5 mm. So you can see some sub elements are erroneous. If you accept this offset without this sub element, click yes. So if I click yes, all the sub elements means whatever the elements that are not offsetting. Okay, if I click yes, you can see some patches are not offsetted. This patch is not offsetted. This patch is not offsetted. These side patches are not offsetted. Any patches, right? This radius is not offsetted. So if you see majorly the radiuses are not offsetted. This radius is not offsetted, right? All these surfaces are offsetting, no problem. Only radiuses are not offsetted. Okay. So most of the surveys are not offsetted here. You can see here problems. So what we'll do, I'll delete this offset now because there are errors, right? So now I'll offset it into the patches, means flat surfaces first I'll offset. So select the offset command, right click, create multi-extract, and I'll select these two surfaces that are flat. It can offset easily. Okay, 2.5 offsetted. Then this flat surface also can offset easily. Okay, so that is the another offset I'll create. Without radius, don't select radius, just select the surfaces. These patches first I'll select. Without radius, okay? These radiuses I'm not selecting. This and this bottom radius I'm not selecting. Only these patches will select. Okay? Only these side patches we selected. Click OK and click OK. Okay? It is offsetted. Then these patches flat, that also we can offset. Right click, create multi-extract. This and this two. Okay? So here three offsets we have, offset 2, offset 3 and offset 4. So here now we need to create a single offset surface using this all three. So here intersections are not there, right? So first I'll create an intersection. So I'll extrapolate this all the surfaces in curvature continuity. Curvature means flat surface we can offset. Sorry, extrapolate. Reduce the value. Tangent continuity. Point continuity. Okay, point continuity. Why? Because from all sides I am increasing the length of the surface. Okay, from all sides we are increasing. That's why point continuity. Here also you can see this boundary. Either boundary also you can extract. Okay, this boundary, this complete boundary. So this I need to extra because extrapolate. If I do the extrapolate here, so it will intersect here, right? And I can trim it. Radius will give later. Extrapolate. Okay. So these two are intersecting now. You can see. If I create the intersection of this patch and this patch, so I'll get a intersection line. So from this intersection line, you can see the extra surfaces. This bottom extra surface we need to remove. Okay, and this insert inner extra surface. Use the split. Okay, so bottom surface removed, and this inner surface also removed. So what you can see is this complete single surface, split 1 and split 2. You can see this proper surface we are getting. So I'll join this. Okay, and now these surfaces also. So this offset also I'll increase, extrapolate, I'll increase. Okay, further. So we can create an intersection. So 6 mm it is offsetting, extrapolating, no problem. Extrapolate. Okay, and here I'll create an intersection of this and this patch. Okay, now extra surface I'll split it out. Split and split. Okay, so we are getting here split 3 and split 4, that I'll join. So we need to create at the end single surface only, that is offset B. Okay, so this is your offset A and this is your offset B. If I cut the section, you can see it is perfectly matching to the 2.5 line here. Okay, throughout. That is your offset surface. Still, there is a gap, right? So this side we need to increase to match this point. Here also we need to increase the length to match this point. So how can I match? Again, extrapolate I'll take, and this edge I'll extrapolate in the point continuity. So from all side it will extrapolate. Okay, extra surface will trim it out later. Okay, and now we'll take an intersection of this patch and this patch. Okay, so here this error is coming. So error is that this here no intersection. Here also no intersection. If I keep all sub element, so you can see here no intersection is there. Here no intersection is there. Okay. Here also no intersection, no intersection, no intersection. So now we need to increase the class A surface bond edge by 1 mm or little less micron. Okay. So here to increase this, now we are doing the A surface modification, right? So you have to activate the A surface modifications define, and I'll do the extrapolate of A surface now. Extrapolate 1 mm is also sufficient, no problem. This edge. Okay, if you have confusion, what we'll do? I'll hide the class B surface so we can get this edge. I need to extrapolate, right? That's why. So I can select easily. Select the extrapolate 1 mm. Okay. Tangent continuity, point continuity. Point continuity not taking properly, completely, right? So tangent continuity will take. Okay. So it is added extra. You can see now here intersection is happening properly. So like this throughout the surface we need to create. Okay, reduce the value and check. Not happening, no problem. Leave it. If not increasing, no problem. Leave it. We'll see that later. Here is the error, right? Okay. This patch having a problem. No problem. So whatever not extrapolate is happening, leave it. Okay, this side is having a problem. This side is also. So this patch is having a problem. Okay, this patch. So here I'll create a boundary in tangent continuity. Okay, click OK. Okay, and I'll extrapolate it. This patch. Okay, we'll reduce to the point one and we'll check. Okay, point one it is taking, right? Point one. Then I'll reduce further to the point two. Point two is not taking, right? No problem. We'll do the point one. Okay. So point one till this. Okay, but here you can see the problem. So we extrapolated, but this is extra something is coming. Okay. So this area having a problem, no problem. The rest we can extrapolate, right? So what I'll do, I'll remove this thing. Okay. So you can use the join command and here sub element to remove. You can select this patch to remove. So it will remove. Okay. So now our this is edge is clear. Okay. This side also you can get the same result. See, this also I'll remove. Otherwise in single only will remove. Sub element to remove this face also. Okay. So now we have a clean thing. Okay. Again, what I'll do, I'll create a boundary of this thing now. Okay, complete till this edge, and again I'll run the extrapolate. Okay, now taking, increase it. Now it is taking completely from all the sides. So sometimes what happen, extrapolate will not work for 1 mm, 0.5. So you reduce the value to the till 0.1 and increase the 0.1, and then that 0.1 you can increase further so it can give you the result. Okay, so now it is increasing, see, in a single line. So only problem now remaining is, see, from all the side intersection is happening properly. The only problem is at these corners. There is a no extrapolation is happening, right? So here, what we'll do, we'll create a surface manually either, or we have to think what to do here. Manually means multi-section we can create. Okay. So first, I'll try with the point one for this edge. Okay, not working, no problem. So I'll create a boundary with the point no propagation, and this patch I'll select. And in the tangent continuity, it is taking complete, right? So no propagation is until this only. Okay. So I think this patch will extrapolate. This patch we can extrapolate. Okay. This is extrapolating, no problem. Okay. Then here also with the no propagation. So single patch now I am trying to extrapolate because collectively it is not taking. See, single it is taking. So here if completely it is not taking, you can use the single method also. This patch only will try. Okay. Now it is extrapolating. See, boundary till this extrapolate. Okay. So single is also fine. No need to do in a single click. Okay. Okay. Here is a problem. So I'll reduce the value and I'll check. See, still point one not taking, no problem. So here now we don't have an option. I need to create a manual surface. Here this edge I'll check one time. because the surface quality is very bad. That's why it is creating a problem. Check with the point one, not take, no problem. Okay, here we need to create now multi-section. This point to this point. Okay, multi-section, this line, and guide curve will be this guide curve. Only guide curve we have. So surface will be created. Okay, like this. Otherwise, another method is C. Another method what you can do, select this, select this surface and remove this patch separately. Okay, from the join with the sub element to remove. And here you need to click on the create join with sub element. So it will remove that patch but keep. Okay, click OK. So you can see two joints you will get. This is a basic join, base joint, and this is your single surface that we removed. Now what we'll do? Now we'll try to extrapolate this edge. Okay. Sometimes this will also work. Okay. So now only this. If I take the intersection of both this and this, keep using this extract and select this. Okay. So whatever commands I am using, just check the video twice. Then you will understand. Okay. If something is new, check this. I'm using the same command, split, extrapolate only, but not like any advanced commands. Okay, simple commands only I'm using. Now I removed it. Okay, so now you can see it is coming smooth surface. So multi-section is also no problem, but that was not proper multi-section. That's why I avoid it. Okay, so now it is fine here. Here also same thing will do. Quickly I'll extrapolate this. Okay, same process you can follow. Okay, we need to extract the boundary. Sorry, in the no propagation. So single I can extrapolate it. Okay. And this all the extrapolate will join. Manifold error. Manifold error means it is showing me the overlap things. So I'll check it. What is the problem? This is a single surface. This is extrapolate 15. Okay, this is extrapolate 16. So every extrapolate is taking the complete base thing. Okay, no problem. Just keep one here. Okay. So problem is here. Now I'll take this completely. So manifold error means overlap. The surface is overlapped. That's why. Okay, now it is fine. Okay. So here also we'll do the same thing. Join this surface and this patch I'll remove separately. This patch and create join with subelement. So it will keep there. So this is my separate surface now. And I'll extrapolate now this. Same thing what I did in that side. Okay. And then I'll create a intersections of this and this. Using extract single, this line only I need to extract. Okay, so other things I can remove. Split this to this. Okay, so that extra surface will be removed. Okay, so now everything is done. This join it and this split 6 I'll join again to create a single join now. Okay, so this is our extra updated class A surface and this is my class B surface. So if I take now class A surface in the color, so you can see from all the side it is intersecting, means ready to cut. So we'll create an intersection now. Intersection of this class B and class A. So intersection line is coming without error. So extra class A surface, I'll split it down. Split. This is my class A surface and from the intersection line. So extra is removed and extra B surface also will split it out. Extra B means this is extra surface. Split. Okay. So now both the things are done. Now if you check the section also, it is perfectly matching to this point. The section is following. Here also properly matches. Okay. Now we can create a, this is my class B surface and this is my class A surface. Now class C surface. So closing where required, closing required here and here. Okay. So for closing, just 1 minute. For closing here, what we need to do, here closing is required, C surface. So closing, see, this is my tooling direction, normal. So C surface I need to create here. So my C surface is parallel to my tooling direction, not perpendicular. Last session it was parallel, perpendicular. So we created the blend multi-section. But here we are not going to use the blend or multi-section. We need to use the sweep with the draft direction because here 0 degree angle we cannot keep. So for example, here if I select this in the point continuity, okay, and if I run here a blend command to close this first curve, support, and second curve, support. Okay, arrow direction same. Here point continuity and point continuity if I use, You can see closing surface is created, right? This closing surface is created between this edge. This section I'll hide for all. Okay. And now here also I am going to create, but here what I'll do, I'll create this surface with drop direction. Means if I select this line and then I'll use the sweep command. Sweep in the second line type, we have to select with drop direction. Okay. So guide curve is this and drop direction is tooling direction. So surface angle is, this is 90. We want 0. So 0 will be vertical surface. Okay. And arrow direction is this arrow direction I'll select. Length of the surface I'll keep, this offset length is 2.5. So I'll keep more than that. That is 4 mm I'll keep. Okay. Surface length. Now what we'll do, this extra surface I'll cut down. So I'll split it out. Split this by B surface. Okay. So extra surface will be removed. So both blend and sweep command we use, blend and sweep, right? Both outputs are same, right? But you will notice the difference later. Now see here, this and blend and this blend, right? Both are C surface. So I'll join it, but technically it will not join because they are far from each other. So just for selection purpose, uncheck the connectivity and click OK. Now I can select it single join, right? This also B surface. Okay. One more thing you need to do before this. Okay, no problem. I'll explain this first. So this is a B surface. Define it. Okay, join. And class A surface also we have. This is the class A. Join. So we are creating join ABC. Where it is. Join A, join 13 is the class A. So change this geometric set to the A surface modification or this main classes. So it will come out. This is my join A. Okay. Then this is my join B. Change geometric set to the B surface. Okay. And this is my join C. Okay. Join ABC. Final join. Select this. 1, 2, and 3. Okay. This is your final join. Check with the boundary command. Error is coming or not. Error is coming means it is ready to solve it. Okay. The thing is here. Now, if I run the draft analysis onto the surface for final checking, so this is draft analysis I have. I'll double click on this. I match the tooling direction. Okay. So you can see here, this surface is red and this is blue. Blue is our parting line. Means if I flip this, this will green. If I flip this will green. So both are green surface. Only color is not changing. The problem is here. The problem is this surface 0 degree. So 0 degree surface we cannot keep 0 degree. Okay. Either we need to maintain at least 0.5 degree or 3 degree. So where you want to keep your parting line depend on that. So parting line at this edge, top edge or bottom edge. If you want to keep top edge, then 0.5 degree draft we need to provide to this. If I want to keep this edge parting line, then I need to keep it 3 degree. Why? See, here this surface and this cavity side I need to clear into the cavity side. Means this surface and this class surface. If I clear into the cavity side, then parting line will come at this edge. Okay, and this and class B means core side. If I clear class B and this scissor paste, then parting line will come here. So where to give the parting line? So the general rule is if I normal the tooling direction from the viewer's point, okay, then parting line we are keeping onto the B side because on the A side the parting line will be visible to the customer or who is like the viewer, right? So we have to hide the parting line. So that's why I need to shift the parting line here. So if I need to shift the parting line here, then this surface I need to clear into the cavity side. And if I am clearing this surface into the cavity side, then this surface degree will be 3 degree. Then only this will be green and this will be green. Both are green. So see here what you need to do simply. If I want to change the value of this, see here blend I used and here sweep I used, right? So if I select the here one command you are getting that is quick select. Select the quick select and select the any surface onto C. You can see it is giving you the parent command blend center graph. So this blend we created right here. So blend here we are not anything about angle. I cannot change the angle. But in the sweep command, if I go quick select and select this, sweep is the parent. I'll select the center graph. So this is the sweep command. So if I want to change the angle, I can change. Okay. How many degree? 3 degree. Preview. Outside arrow. This error is coming why? Because your B surface is short here. B surface having a gap. Okay. So simply what we'll do here, B surface. Okay. Join B is our final B surface, right? So here we need to increase the length of the B surface. Okay. Increase the length of the B surface. So final join I'll hide. Okay. And I'll define the B surface. And I'll increase the 2 mm is sufficient from all the sides. Okay. From all the sides. Okay. This is your join A and this is your join C. Okay. So here what we need to do, we need to change the angle of this. Okay. We need to change the angle of this. So to change the angle here in the sweep, first we need to work. Okay. So this join I'll delete for a while. And this blend and this is my sweep. Right. So this sweep angle will change to the 3 degree. Okay. Angle is changing. Click OK. So split 9 है, delete, not required. Okay, so this is a sweep we created. So how can you check if I normal this tooling direction So you can see this complete C surface visible to you. Means it is going to clear into the cavity side. Here also instead of blend, we'll use the sweep only because blend is not useful here because C surface is parallel to the tooling direction. Again, we create a boundary, sweep with draft direction, guide curve, tooling direction, outside draft 3 degrees. Okay. And if I normal the tooling direction, you can see both C surfaces are visible. Okay. So here now what we need to do, we need to cut this, right? Cut this final trimming. Okay. In the C surface, this sweep, change geometric set to the C surface. Okay. So when you are not defining the surfaces, it will create a problem. So two sweep we have, sweep 1 and sweep 2. Okay. So now easily what we can do, we can split it out, the C surfaces, extra C surfaces. So split this from this other side, split this from this other side. Okay. This is also extra surface, so that is belongs to B surface. So define the B and split it out. So this session is looking like complicated, but this is, if you rewatch it, you will understand. Okay. Now everything is done. So this split and split pair will join as a final C surface and uncheck the connectivity because technically it is not joining. Okay, uncheck the connectivity. Okay, so this is C surface, change geometric set to the C surface. Okay, this is my B surface final. This B surface we can delete. This is my final B surface. So I'll join it. Join B, join C. Okay, and we'll create now final join again, updated, join C, join B, and join it. Okay, so this is my final join. Error is also coming. So now I'll check the draft analysis again. See now, this is green, this is green. Why? Because the angle is 3 degree. Now you have a clear cut two colors. You have a clear cut two colors, right? So that is your parting line. If I flip it, you can see clear cut two colors. Okay. So this is your core side and this is your cavity side. Okay. So now only what you need to do, create a solid body out of this. Closed surface, sorry. Final closed body. Closed surface is this is your solid part. Okay. And now we can extract the lines for parting line. Okay. For parting line, I'll still run the draft analysis onto the solid body. Okay. So these two colors I am getting, right? So I'll extract it. That is my parting line. So I'll go to the parting line now. Select, sorry, select GST. Select this. Extract, sorry, extraction. Extract we need to do, sorry. Multi-extract. Okay. Click OK. Single I'll extract. Okay. So this is single line. These two lines, these are nothing but your parting lines. So join it. Uncheck the connectivity. You can isolate this and change to the 1 and 2. Okay, same like this tooling direction. So this is your core side, cavity side, parting line is this. Okay. So now this is your part is completed with proper manufacturing things. Tooling direction complete part is clearing. Parting line is created. Tooling direction is created. Closed body is created. And it is matching the sections also. If you see this, it is matching the section. Only fillets are pending. So fillets, how much you can give into the solid? 3.5 and zero point 0.3. Okay. 3.5 and 0.3. Define this. Go to the part body. Fillet 3.5, 0.3. Okay. Now you have proper matching section. Okay. So sections, don't take it like a section. This is a like starting of section. Section is another topic. Just for close body, I explained. Section like will take 4 to 5 sessions separately. So don't think about this that much. Only here, just an introduction. Okay. So this is a solution for this CAT test. Okay. So now anybody having doubt, you can ask. Okay. This is you need to practice. Okay. I'll share you the file also. So you can practice it. If not understanding, you can check it, the session again. Okay. Check twice. Okay. So I'll share the recording. Okay. And this practice file also, step file. Just open it. And tomorrow if you have holiday, you can practice it also. Okay. Any doubt, you can contact me tomorrow also.
Excuse me, sir.
Yes.
Sir, I'm not able to open the previous session.
Which
Uh,
session?
Session six, session number six, recorded session. I'm not able to open
You
in
can
the session.
download and open, na. You can download. If you are opening online, na, sometimes it will not opening. That's why.
Okay. Okay,
Just
sir. I'll
try to
try.
download it and then open it. So it will open. Otherwise, I'll resend other link.
Okay, sir.
Okay. Okay. I'll share the data. Okay. Thanks for joining. Good night.